So let's visit an example where we are gonna calculate the confidence interval using our formula. And it says listed below are speeds in miles per hour of cars measured from the 5 freeway near Santa Ana, California, and this SRS is obtained at 3:30 p.m. on a weekday, and the speed limit for this road was 65 miles per hour. They provided us with the data, they provided us with summary statistics, as well as a graph, and they want us to construct a 95% confidence interval for the mean speed. So first, we have to determine what distribution are we using. Are we going to build a t-interval or a z-interval? And the key here is the fact that we only have a sample standard deviation, not a population standard deviation. We only have S. So this tells us, oh, we're going to use the t-distribution to make a t-interval. So again, what's the difference when we do this is when we find how many standard deviations away from the mean we're going to use, we're going to end up using the t-distance, the t-distribution. So let's first find, according to our book, is our margin of error. Which your book also calls the error bound for the mean. And recall, this is just going to be t alpha over 2. And I'm going to show you a nice, easy way of finding that on StatCrunch. And we're going to multiply that by the standard error. So let's do this first. We already have S. Let's figure out n in just a second right here. We have to do this just by counting. And I can see that based on these data values, there are 12 of them. So our n is 12. So we have our S, we have our N. The only thing we're missing now is T critical value. So let me show you on StatCrunch one way we can easily find this. If I want to be 95% confident, it means we want to capture 95% between these values. And so going over to the StatCrunch calculator, we're going to go to calculators T. So yes, you can probably look it up on the table as well if you choose. But the t calculator is nice because I want to capture 95% in between. So if we click on the in-between method, you'll see that we can type in our degrees of freedom. Well, going back to our work, if we have n is 12, then our degrees of freedom is going to be one less than that, 11. So we tell the calculator 11 degrees of freedom. And we also tell it that we want to be 95% confident, so the area between should be 95%. And here we go. There is our T alpha over 2, the boundary for cutting off the inside 95% and the outside of 2.5% on both sides. So this is our T alpha over 2, our critical value, 2.201. So now we have everything we need to build the margin of error and then the confidence interval. So our error bound for our mean is just going to be 2.201 times 4.08 over the square root of 12. And typing this into our calculator really quick, I get about 2.59. So now that we have our error bound for the mean, or our margin of error, recall that we can actually build the interval by using our point estimate, which in this case is x bar, our best guess for the actual mean. But then we're going to go up and down the margin of error. So this is just going to be 60.67 plus or minus 2.59 miles per hour. And sometimes we want to answer a question like that, but often we'll write it as an interval. So let's actually write it as an open interval in this case. So doing the addition and subtraction, I get 58.08 and for the upper bound, we get 63.26. Finally, of course, what's the most important piece? Let's interpret this interval. So we can say we are 95% confident the true mean speed of the cars is between our interval, which is 58.08 to 63.26 miles per hour. And there we go.